All right, so this is going to be a video about finding the intervals of increasing or decreasing, as well as finding all the extrema and labeling the extrema as absolute or relative, or minima as maxima. And the first example we have right here is the y equals x squared minus x minus 1. So what we're going to do here is to find the increasing, decreasing, to find those extrema, we need to find the first derivative. So that's usually step one, so I'm going to do that really quick. So you end up with that for the first derivative. From here, we need to find the critical numbers. The critical numbers are basically like possible boundaries where the increasing and decreasing can change. It also tells you other information about the extrema. So to find the critical numbers, you have to set the first derivative equal to 0 or undefined. It's important to not forget about the undefined because some problems you're really going to need to know for that undefined. The undefined in this case is not applicable because there is no division by 0. There's nothing that's causing it for expression of 2x minus 1 to ever be undefined. It's going to be defined everywhere. It's continuous. So I'm not going to worry about the undefined, but I am going to worry about this equal to 0 here. So I'm going to solve this really quick, and you should get x is equal to 1/2 as your critical number. From here, I'm going to make a critical number line, and then I'm going to use that critical number line to basically test the intervals for increasing or decreasing using that first derivative. So I call this a critical number line because I'm going to put my critical number on it. If you notice, it only goes in one dimension. It's just going to be on the x-axis, basically. We don't care about what the y is doing. We just care about the sign of that first derivative. So we care about this y prime right here because it's going to tell us what the y is doing. So I just need to figure out what the sign is of that y prime in these intervals. So I'm going to pick a number to the left of 1/2. An easy number to use would be something like 0. So if I plug 0 into this first derivative, okay, not the original. The original tells you the y. We want to actually use the derivative because the derivative tells us what the y is doing. So if I plug a 0 in there, I'm going to get -1, which means that this interval right here is going to be negative. So if the derivative is negative on this interval, the original function will be decreasing on that interval. So I'm going to put a little decreasing down there. And then I'm going to do the same thing to the left of the 1/2. So let's pick a number like, I don't know, infinity is a good number to pick, or 1, or it doesn't really matter what you pick. So say that you pick 1 or infinity. Either way, this first derivative right here is going to be positive. If you picked 1, it'd be 2 minus 1 is positive 1. If you pick infinity, it's 2 times infinity minus 1, which is still going to be positive. So we're going to put a positive here, which means the y is increasing. So if the derivative is positive, the y is increasing. If the derivative is negative, the y is decreasing. So the problem said to figure out the intervals of increasing and decreasing. So I'm going to write that over here. So far we have the increasing and decreasing intervals. Now we have to figure out the relative extrema and then eventually the absolute extrema. So if you notice right here, it's with the critical number line, it is decreasing. So I'm going to kind of sketch what y would look like. It's going to basically be decreasing here, and then it's going to be zeroed out at 1/2, because if you remember, this 1/2 right here is our critical number. It's where the derivative is equal to 0 or undefined, but in this case it's just 0. And then it's going to start increasing from here. Now it kind of matches what the original y is doing over here as well, because it's quadratic, and this kind of looks quadratic. And it's just a sketch, it's just to give us an idea. But by doing this, you can see that at this 1/2 right here, it's going to represent a relative min. It's also going to represent an absolute min because, as you can see, it doesn't get any smaller than that 1/2 there. So I'm going to write over here relative min, and it occurs at 1/2 for the x. Now we need to figure out the y. In order to figure out the y, you have to plug that into the y equation, which is the original equation, the OG equation, if you will. So you have to plug this 1/2 in there, and you will get 1/4 minus 1/2, which is negative 1/4, minus 1, which is negative 5/4. So that would be the y coordinate for that problem. Now we also stated that this relative min is also the absolute min, so I'm going to write absolute min is also at 1/2 negative 5/4 for the coordinate. Now, we also need to find the absolute max, but if you notice, this y value goes up forever. Okay, this y graph goes up forever, so it never actually maxes out. So there is no absolute max. Also, there is no instances where it forms a hill, just this valley. So this valley right here basically is what represents the relative min. But if it ever formed something that looked something like this, then there would actually be a relative max, but there isn't. That never happens. So there is no absolute max or relative max because of that. And this basically ends up being your answer. This whole thing right here that I'm highlighting. So that's basically how to figure out the intervals of increasing, and then any extrema that occur using the first derivative. If you have any questions about anything in this video, let me know.